Hi everyone, today's video is the first of a series of videos on indices. In this video, I will be explaining to you about the first two laws of indices. The links to the subsequent videos will be up in the description below. Before I begin, I would like to mention that there are two terms which I will be using regularly in my videos. The number 5 to the power of 4 has base 5 and index 4. You should find this familiar as it was used in the topic of prime factorization in secondary 1, where you were required to leave answers in index notation. Now let us look at the first two laws of indices. You will find some similarity between these two laws as they differ only by the operation between them. Both laws involve the multiplication or division of two numbers of the same base A with equal or different powers. In example 1 part 1, we shall take A to be 3, M to be 4, and N to be 2. In secondary 1, you have learnt how to decompose 3 to the power of 4 into 3 times 3 times 3 times 3. The power of 4 simply refers to the number of times base 3 appeared in the multiplication. So power 4 means 3 appeared 4 times and they get multiplied together. Likewise, 3 to the power of 2 means I see 2 3's getting multiplied together. And when these two sets of numbers get multiplied together, we get 3 to the power of 1, 2, 3, 4, 5, 6. This is similar to saying I count 4 3's and 2 3's and I add them together to get 6 3's. And therefore it means 3 to the power of 4 plus 2 gives us 3 to the power of 6. We shall apply the same trail of thoughts to observe a certain pattern. 7 to the power of 5 simply means 7 times 7 times 7 times 7 times 7. So power 5 refers to 5 7's getting multiplied together. 7 to the power of 3 means 7 times 7 times 7. And when these two sets of numbers get multiplied together, we get 7 to the power of 1, 2, 3, 4, 5, 6, 7, 8. And likewise, this is the same as taking 5 7's plus 3 7's to get overall of 8 7's. So we shall now try to generalize this relationship. 3 to the power of 4 times 3 to the power of 2 gives us 3 to the power of 4 plus 2. 7 to the power of 5 times 7 to the power of 3 gives us 7 to the power of 5 plus 3. And therefore, a to the power of m times a to the power of n gives us a to the power of m plus n. I'd like to draw your attention to the fact that when it is a multiplication between two numbers of the same base, the power gets added together above one single base A. In the next example, example 2, we shall be tackling law 2 of indices. In example 2, we have 3 to the power of 4 divided by 3 to the power of 2 in part 1. We can convert this to fraction. 3 to the power of 4 divided by 3 to the power of 2 is none other than 3 to the power of 4 over 3 to the power of 2. So when we decompose the numerator and denominator, it becomes 3 times 3 times 3 times 3, and that's 3 to the power of 4. In denominator, we have 3 times 3, which is 3 to the power of 2. So that's 3 to the power of 4 divided by 3 to the power of 2. We can take the 3 in numerator, divide by the 3 in the denominator to get 1. So these two 3's get cancelled out. Similarly, we repeat this process until we run out of 3's to cancel in the denominator, and therefore we're left with 3 to the power of 2 in the numerator divided by 1 in the denominator. We shall now look at part 2 first before we try to observe a certain pattern. 5 to the power 7 divided by 5 to the power 3 is the same as 5 to the power 7 over 5 to the power 3. In the numerator, we have 5 times 5 times 5 times 5 all the way until we get 7 fives. 1, 2, 3, 4, 5, 6, 7. And then in the denominator, we have 5 times 5 times 5, a total of 3 fives in the denominator. We use the same process of cancellation, and we have 4 fives in the numerator. So we have 5 to the power of 4 divided by 1, which is 5 to the power of 4. Now, notice this. In part 1, we have a total of 4 threes in the numerator and a total of 2 threes in the denominator. When we cancel them off, we are actually finding the difference in the number of threes between the numerator and denominator. So that means we actually take 3 to the power of, since there are 4 threes in the numerator, we subtract away 2 threes in the denominator. And unsurprisingly, 4 minus 2 gives us the overall 2 in the final answer in its power. And in part 2, similar thing happens. In numerator, I have a total of 7 fives. In denominator, I have a total of 3 fives. And when we take 7 minus 3 in the power, we get 4. So this process is really counting the difference in the number of base appearing in numerator and denominator. So we shall now try to generalize this observation. So 3 to the power of 4 divided by 3 to the power of 2 simply gave us 3 to the power of 4 over 3 to the power of 2, which is 3 to the power of 4 minus 2. Similarly, 5 to the power of 7 divided by 5 to the power of 3 gave us 5 to the power of 7 divided by 5 to the power of 3, which gave us 5 to the power of 7 minus 3. And likewise, we can generalize this into a to the power m divided by a to the power n, giving us a to the power m over a to the power n, which gave us a to the power m minus n. Again, I would like to draw your attention to the fact that if it's a division between two numbers of the same base a, the power gets subtracted. So now we can formalize the relationship for law 2. A to the power m divided by a to the power n is a to the power of m minus n. And so therefore, observe this very important observation. If it's a multiplication between two numbers of the same base, the power gets added. If it's division between two numbers of the same base a, the power gets subtracted. And I hope this video helps you to gain a bit of understanding in law 1 and 2. So stay tuned for other videos which I will be tackling other laws of indices as well as certain definitions. Thank you so much for watching this video. Goodbye.